Hi everyone. Quick introduction about myself. So I have 10 plus years of experience in software industry, mainly working across development roles. I have been on both sides of the table, both as interviewer as well as interviewee. So I have seen very closely how these DSA coding interviews work from interviewer side. Like I've been in many loop interviews and debrief meetings, and I know that what are the red flags and what the interviews look for in DSA coding interviews. So I want to bring all those insights into your DSA preparation. You might be thinking it's like another DSA journal. So I'm not going to, so I know that there are lots of resources for DSA. So I'm not covering from basics. So you can use this material as a complement to bridge any gaps in your preparation. I'm assuming you are already familiar with DSA basics. So we'll go through all kinds of patterns, DSA patterns, and like I will be doing a live coding on LeetCode and on some selected problems for each of these patterns. So one important thing is there is a scalability aspect also. This is seen mainly for like L5 plus roles where after you solve a DSA problem, you'll be asked to like think in terms of scalability, and I will cover that aspect as well. Yeah, now why DSA? So DSA is not going anywhere, and among all this, like all this AI mania and AI hype nowadays, it's still there, and it will be there in the future also in coding interviews because the filtering starts with DSA only, whether it is online assessment or phone screen. So it will be mainly judged, and even for staff engineer roles also, this is kind of acts as a uh, filtering, like elimination kind of interview. Hiring bar is very high nowadays when we compare with the COVID times. So we need to prepare accordingly. I'm not discouraging you, but I'm just telling the truth out there because we need to prepare really well, and we need to like learn from our mistakes and look for any red flags in the preparation itself. DSA is all about finding patterns and finding them quickly and applying them to the problem statement that is given to us. Yeah, I will explain you like in a phase-wise manner to see how that works. Consistent practice is the key. Yeah. So we need to regularly practice DSA, otherwise, like we'll be out of touch basically. So at least try to solve one problem, at least one problem a day, and that consistent practice will definitely give you like rewards later. Learn from mistakes during your preparation time. Any subtle bugs, you just document whatever you see. Once you solve a problem, you see where you are making mistakes. Make a note of it because you'll forget it later. So I will start with the sliding window pattern first. Why not other patterns? Why this? Because this simple pattern compared to DP and drops and all these things. It's applied in simple array, but this is often overlooked. And the reason I'm saying this is like when in the interview setting, when this problem is given, it's possible that you might make some mistakes, and there are subtle bugs around edge cases and corner cases. Yeah, so first master these simple patterns and then move on to like other complex topics like DP graphs and those things. Oh, yeah, need to take care of extra care for edge cases because yeah, these very subtle bugs, harder to debug in, especially in the setting of interview. So it's better you kind of practice this during your preparation itself. So for this, a standard code template is you need to have a standard code template and for making to like write code faster. So the thing is, sliding window pattern comes when we know the brute force solutions gives us dwarf and square solution, and we need to optimize it further. And then comes the sliding window pattern. You can look for the keywords like subarray or substring. That means we're looking for a continuous segment, and that is the key. And sliding window pattern can be applied in this kind of setting where we are looking for it. We are looking like inside a continuous segment. So it will be clear. So now it's all abstract. It will be clear when we solve some problems. So the cool thing about this pattern is it will reduce the time complexity O of n, and this is the highest possible optimization. So if you're given this problem and if you know that sliding window pattern, that's about it. Like you solved it the most optimal. You came up with the most optimal solution. You can't like further optimize. So that's advantage of this pattern. For this pattern, just let's imagine a queue, right? Imagine a queue with so you are given a bigger array, and just I'm drawing this queue inside, like left pointer and right pointer. And the invariants for this are like the right pointer, we iterate from the right pointer, which can go from 0 to the end of the index. And the left pointer is always less than or equal to right pointer. These are the invariants that we maintain. So first process the right pointer from 0 to end of the array. Q can be only expanded from right side. And so while we are iterating, we are at right pointer and we process that element based on some condition specific to that problem setting. We decide either to expand it or not. So in this case, in this diagram, we can see that we are deciding to expand it. So this window is now from L to R dash. So the queue is expanded. And while iterating, we can like process some logic based on the current, like let's say maximum length, what is the length? So that depends on the problem. Yeah. If you decide not to expand the queue, we'll try to shrink the queue from the left side based again on the condition of the problem. It depends on the problem setting. Now the real twist. So we won't be actually using a queue data structure. Queue is just simulated with the left and right pointers here. Yeah, and that's about it actually. It's very simple algo, and you just need to know just these 2 points, like how to expand the queue, how to shrink the queue, and all the problems are variation of this very simple algorithm, right? Let's let's go to this template now, right? So we initialize left pointer and right pointer to 0 first before doing anything, and this is our main loop. And this main loop, we are iterating on right pointer. It iterates from 0 to n minus 1. Step 1 is process the right pointer. Do any computation based on the problem, whether it's like updating map or any computation. So you process that current element, and based on the condition given the problem, depending on the current iteration of right pointer, we need to decide whether to expand the window or not. So this is the second step. If you are expanding the window, increment the right pointer, and again come to the right pointer. And I mean, basically, the control will come back again to the right pointer. And we can have like some computation here also actually. Now, the third step is if we are not deciding to expand the window, we'll check whether we can shrink the window from left side. And we need to make sure the invariant left pointer is less than right pointer. We need to make sure that. and this condition is satisfied. And yeah, this depends on the problem actually. With the left pointer, we're already incrementing. This subtle thing, it depends on the problem. But right pointer, we definitely need to increment because we are using a while loop. Yeah, these three simple steps all we need to master sliding window. Now let's solve a problem. Given a string, find the length of the longest substring without duplicate characters. You see the keyword here, substring. This is the key. Just giving some ideas. So first, okay, a string is given longest substring without any duplicate character. So if you see in the strings, ABC is the maximum possible, and it can be CAB also, and it can be ABC also. Um, and if you see in this, it's just only B. And the third example is we can see it's either WKE or PW is not possible, only 2 letters. Yeah, KEW also 3 letters. Now let's try to solve this. First, before jumping into an optimization, I would suggest just to think of brute force very briefly how it works. So it will give us upper bound, like what can be the maximum upper bound of time complexity, and we can optimize based on that. So in this case, brute force will be like have two for loops, right? And then so let's say so let's take this example, right? So in the first loop I will be like looping from index 1, which is A, and then I keep on checking if the next character like we can use some kind of a set hash it or any data structure like that, and we will see that the next element is not contained in that set. So let's say from A, B is not there, so expand, like we can go further, go to C, we can go further. So and A again came, so A is already there in set, so we need to stop here. So max length till now is 3, and we'll come out of the first loop. And now we'll again first loop is done, length is 3. We'll again start from the second index. We can go from B, C, A. Again length. So again B is a match, so we need to come out. So like this, you can continue for all of these elements. So the time complexity will be O of n square because there are two for loops. In the worst case, we need to like iterate over the full length. Now this is a classical example how sliding window can be applied here because we are looking for substrings, right? So now let's apply our pattern here. Uh, so this is our pattern. Let's try to apply this. First, write so these corner cases error handling is also very important because it shows that you are thinking about you're writing production ready code. So if it's null and length, I'm just returning 0. And now define left pointer. And we'll define so try to define variables like very clearly. That is also very important. Don't just use size AK. This is not completely programming, so these things matter actually. Um, yeah, and then we need a set also, right? Because how do you check whether that element exists in the current, like we're considering a queue from left to right, right? Within that window, whether that element is contained or not. That we can check with the help of a set. Otherwise, we need to again iterate over the entire queue, and that will increase our complexity. So let's have a queue here. Now I'm iterating over right pointer. So our step number one, I will process the current element, which is caret. Uh, this is the current character, which is the right character. And so we need to check so the whether this is already there in the set or not, right? If it's this is the condition specific to this problem, we should check if it's not. If it's not, we can increment. Let's have in your mind this example, right? I'm at A, I'm in the first index, so A is not there in the set yet. So I need to add that to set, right? And then I need to increment this, and I will come out of this loop because till again go back to this again, right? I'm incrementing the pointer. So this is important here because we need to increment this, otherwise we'll get an infinite while loop. So A is done, and I'm again going to second index, which is B now, right? So B will check it's not there, right? We'll again add that increment right pointer, and so on and so forth. It will continue till C. Yeah. And one more thing is, while we are doing it, we need to compute the maximum length also, right? You can have it here. So we'll compute length also. We'll keep on tracking the maximum length till now. Max length. So naming is also very important in introduce. So for OA, it might online assessment test those things. It might not that important, but in like full loop introduce and phone screen also, it's very important. So I'm actually computing max length here. So in the first iteration it was 2, and so we just need to compute this difference between right and left pointers. Right now, now we are at ABC. So till now the max length is 3. Now we again come to A. So now this loop I will check it. It is already there in the character. So till now we are expanding. Now it's time to shrink the queue, right? And for that, check what is the left character, right? And we can keep on ABC. So I'm just have a mental model here. So what the example, right? ABC. So I want to remove this here, right? So let's try a different example actually. BAC, right? So now we are at A. We know that there is a duplicate here. So we need to remove B, right? All the elements that are there in the set, which are not actually matching the current right character. So the condition is right character with the right character equal to left character, right? We If it's not, we can remove that character and we can shrink that window. So first, make sure our invariant is met because it should be always is the right pointer and right character. It's not equal to left character. I mean, we are checking left character not equal to right character. We can shrink the window. Shrink the window means just increment this pointer. Right, and one important thing is we need to remove this from the map also, from the set also, right? That is also important. Mhm. And then we need to have this statement also, right? Left char equal to this also needed because we need to update left character after it is like after the next element from the left side. So we are done with the string the q condition also. We need to increment a pointer. So in this case, left pointer also needs to be incremented one more time because let's say a we are at a and we came out of the loop, and we don't want a again because a is already there in the right side. So we need to again increment left pointer so that now the left window starts at C. Yeah, I guess that's about it. Return. Yeah, let's see. Okay, that's good. Perfect. Yeah, now we are done with this problem. So in some cases, especially big techs like Google, especially Google, right? There is a possibility that for higher roles, for L5 and L6, they might check your expertise on handling the skill, and so they can just simply ask what if there are huge number of input data like billions, 4 billions, and like 10 billions that won't fit in the memory of a single machine. So how do you solve that? So the solution is kind of divide and conquer, right? So for this case, let's say the same input. Let's assume we have a hypothetical machine that can only store 3 characters, right? So how do you solve this problem then? Right. So it's kind of like the bigger problem we are kind of simulating it here, right? The thing here is we can't parallelize this because there is a dependency, like because we are checking for continuous sequence, right? So what we'll do is first chunk. We'll solve this. Each chunk by chunk we'll solve this. So first we'll solve this ABC, and we know the max length is 3. And apart from the max length, for each segment, right, we need two output uh, objects, right? One is the max length, and another is the data structure of set also we need, right? We pass that to the second segment now. So first segment is like solve this, max length is 3, and we need we need a left and right pointers also. That is important thing actually. I will tell you why. Based on that, we can anyway compute the length, right? So these left and right pointers are the values corresponding to the max length, right? And the set also. So this is the output of first segment out. Now when processing second segment, what we need to see is uh, whether right pointer is at the boundary, right? If the right pointer of segment 1 is at the boundary, we need to continue in the second segment from that point on. There is a dependency in that case, right? We need to use that set, and we need to continue from here. Like let's say this example, let's say there is a math, so let's consider this for example, right? If it's a DEF, so we need to continue. So the length will increase again. All right, like we'll start from D, and now the length will be 4, right? So there are two cases here. So that is one case. And the other case, like in this case, in the first case, not in the first case, like so that is one case. Let's say A is there, DEF is there. So in this case, its length right pointer stops at B. So now when processing DEF, it becomes a complete independent problem, right? Yeah, there is that subtle distinction. Like there are certain boundary cases that we need to look for. So yeah, there are multiple cases. So usually they won't ask us to solve this, but they will ask us to explain the approach, and this is how we can do. We can say divide and conquer, and we need to see the edge cases, boundary cases, and whether it can be done in parallel. In this case, it cannot be done in parallel. Yeah, so these are the insights actually, and this is very important. If you can't think like in scalable terms, like it's not like L5 or L6, they might down level. Yeah, this is important for higher roles. Yeah. So we'll this is done. So we'll continue with the sliding window pattern, and we'll solve more problems. Okay. Thank you.